Hello students, we'll begin with the topic process concepts. So first we'll see the definition of a process. So process is nothing but you can say it as a program under execution. So you've written a program and you have saved it. So that is just a passive entity. But the same program when you're executing is nothing but you're loading into the main memory and giving the control of CPU, then you can call it as a process. So process is nothing but a program under execution. So these processes require some resources like CPU time, memory, files and IO devices to complete its task. So these resources can be given to the process either when the process has been created or when the process is executing. So when you say system, you can have n number of processes. So this n number of processes can be executing concurrently. Next we'll go to the next topic, that is process layout in memory, or how a process looks like in a memory. So when you say process here in the memory, it consists of 4 sections. So first one you have the stack. So stack is usually used to hold temporary data such as your function parameters or return addresses and also your local variables. Next one we have the heap, that is it's a memory that is dynamically allocated during the process runtime. Next you have the data section. So the data section is used to hold your global variables as well as your static variables. Finally you have the text section, which is used, or it consists your compiled code or your program code is stored in your text section. Next one you have process states. So this is a very important question from a semester exam point of view. They've asked this n number of times. So usually they ask define process and with a neat diagram explain the process states. So I hope you have understood what is the meaning of a process. So process is nothing but program in executing. So when the program is executing, it moves through different states. So that is your process states. So we humans, how we move to different states, like we initially born, that is here we can represent it as a new state. That is, new is nothing but when a process just created, it will be in the new state. So we humans, we move through childhood, then teenage, then middle age, old age, and finally we get terminated. Similarly, here process also goes through different states. So that is diagrammatically shown here. So to begin with, initially the process will be in the new state. So that is process just, or it is created. So now the process has been created. Now the process is ready to execute. So then it will move to the ready state. So usually here we have the ready queue. We have a queue called as a ready queue, wherein all the processes that has come into the system, okay, or which are ready to be executed, are stored in the ready queue. From the ready queue, so suppose we assume in the ready queue we have 3 processes, P1, P2 and P3. So all the 3 processes are ready to execute. Out of this 3 processes, which one should be executed? So that is the task done by the scheduler here. So you can see here in the diagram you have a link from ready to running state, and under that we have written as scheduler dispatch. So that is nothing but the scheduler is going to decide as which process you have to take from the ready queue and give the control of CPU. That is, you're taking a process. So we said that we have P1, P2, P3. So we'll assume P1 is a process which will be taken from the ready queue and given the control of CPU. So then P1 will be moving into the running state. So P1 will be in the running state now. So it is executing and it has completed without any disturbance. Then it will be moving to the terminated state, that is exit. So when it is in a terminated state, whatever resources that had been allocated to that process P1, that will be deallocated, so that resource can be given to other processes. That is one thing. Now suppose we'll come back again. P1 is in the running state. Now suppose we assume P1 requires some input output operation. So we know input output operation is comparatively slower. So what we do is we don't want the CPU to wait until its task input output operation is completed. So in that case, what will be done is P1 will be taken away from CPU and P1 will be sent to the waiting state. At that time, any other process which is there in the ready queue, that can be taken and given to the CPU. So thereby what we are saying here is CPU will be executing one or the other process at a given time. Okay, now we'll get back here. P1 is in the waiting state. Now P1 has completed its task, that is input output operation. Then P1 is again sent to the ready state. So again P1 will be waiting in the ready state for its chance to get the CPU. That is one thing shown in the arrow. Now you can see we have another link from running to ready, and it is written as interrupt. So what is this interrupt? So same, will take the same process P1. So P1 is executing, that is in the ready state. By some chance, we'll say that there is a process which is having higher priority. So priority, so each of the process can be given some priority by the operating system. So suppose we assume we have a higher priority process. That time what will happen is an interrupt can be raised. So what is the meaning of that? We are stopping P1 right now and we are allowing the next process to execute. So such kind of situation can occur. In that case, what happens? There is an interrupt from the running to ready. So this is what is shown in your process state, or you can also call it as a life cycle of a process. I hope you have understood this. It's a very important question. So see the arrow marks properly. From the new state we are going to ready. From ready you can go to running state. From the running you can go to waiting, or you can go to terminated, or you can come back to ready state whenever an interrupt occurs. That is, one is based on a priority, or in case we are going to see some scheduling algorithm later, so there we are going to learn something more, that is about time quantum. So what do you mean by time quantum is each of the process will be given some time, that is it should be executed it should be executed for this time. So if it is taking more than that, in such cases also process can be taken away from the running state and it can be brought back to the ready state. That is what is shown here. Okay, I hope you have understood this. Next we'll come to process control block. So process control block, so we know when you say system you can have n number of processes. So how many processes you have, each of the process will have a process control block. So process control block is nothing but, you can say it as, information about the process will be present in a process control block. So process control block is nothing but a data structure which is maintained by the operating system for every process whatever is there in your system. So this process control block, you can also call it as a task control block. So we know, suppose we have process P1, P2. So P1 will be having its process control block. Similarly, P2 also will be having its process control block. Okay. So we said we are having n number of process. So to uniquely identify the process, we have process ID, which is an integer. Call it as a process ID. Okay. Now we'll come back. What are the information that will be there in your process control block? So you can see information, that is process state. So we already saw the life cycle of a process, wherein a process moves through different states. So in which state your process is currently in which state your process is, so that is being told by this process state. So this information also will be present in your process control block. Next thing, you have the program counter. So program counter, in we know what is program counter, right? So that is going to tell us which is the next instruction that you have to execute by this process. So that information also will be present in your process control block. Then you have the CPU registers. So depending on the architecture, that is a computer architecture, the registers can be varying. So it includes registers like accumulator, stack pointer, okay, along with program counter. So along with program counter, the state information must be saved when an interrupt occurs. So what is the state information? So what is an interrupt? So now process is executing and an interrupt is raised. So that time what will the process do, or what will the CPU do? It will halt the current process and it will shift the control to the new request whatever has come in. So when it is shifting to the next process, the current state should be saved so that you can come back. Once the interrupt is executed, we can come back to the same location. So for all this you require the CPU registers. Next you have the CPU scheduling information. So this includes information like process priority. So while telling about the process state, we spoke about priorities. So each of the processes will be assigned some priority. So based on the priorities, a process can be given to CPU. So all those information will be present in a CPU scheduling information. Next, we have the memory management information. This include information like about the page tables, then segment tables, um, like how much amount of memory can be utilized, the limits. All those information will be present in memory management information. So about page table and segment table, we are going to see in the coming classes. Next one, you have the accounting information, which will be telling or which will be giving the information about how much amount of CPU is being used by the current process, or time limits, and the process numbers. All those information will be present in your accounting information. Finally, you have the IO status information, which include, so we said process requires some IO device. So which devices has been allotted to the process, that information will be present in your IO status. Along with that, which are the list of files that has been opened. So all this information will be present in your process control log. So process control block is nothing but information about process. It is a data structure maintained by your operating system. So for each process, it will be having its own process control block. Thank you.